Hello again! In the last video, we finished setting up the player collecting pickups with that client to server communication, and in this video, we are going to handle the collection of the pickup being collected. So that's the server handling the collection and then broadcasting a message back out to clients. So where we left off was right here with this was collected call, which I told you was not going to work, and we're going to get to how we're going to resolve that. But let's first, just like the last video, take a look at this in a theoretical context, taking a look at this slide. So, as we said, we've on the client sent a collection request to the server, and the server is processing that request. So here we are on the server, we're currently processing a request, and we find that there's a pickup. So we are going to call a function on the pickup called picked up by. We're going to say, hey pickup, you were picked up by this pawn. And then there's going to be some logic that happens in the pickup, and so maybe that's changing some energy value or doing some other stuff. And then the pickup is going to broadcast out to all of the clients on the network that are relevant via this function that we will define called client on picked up by passing the pawn. Now, if you've gone through Epic's tutorial on Blueprint networking, you will know that there's a couple of different ways that you can send a message out to clients on something like this. One is to use a rep notify, a replicated variable with a notification. Another is to do a multicast function call. And that is what we are going to do, the multicast function call version here. If you recall, also, we did set up the be as active flag, and that is replicated with the rep notify, so you could use that as well. But we are going to set up a multicast function call. Once that call happens on the server, it gets executed on the server and then blasted out to all of the clients. So now, back on the client side, I will get this function call client on picked up by and execute it using the underscore implementation version, and I will do things like play visual effects and sounds and so on. Now, you might ask a question, why are we passing this pawn around? Why are we saying, hey, you were picked up by this pawn and passing that back and forth? Well, the reason is because we can't guarantee, if we were to set up a replicated variable, for instance, we can't guarantee that that variable will reach the clients before the function call. So we're passing it through the function call to ensure that that happens. All right, now having looked at this in a sort of theoretical capacity, let's go ahead and do the actual implementation. So we will leave this line here that was collected, and we will circle back to that at the end, toward the end of the video. But for now, we need to switch over to our pickup class, where we will start to define the functions we just talked about looking at the slide. And the first one of those, which is going to be a protected function, because it's only called by the, I'm sorry, this is the version, this is actually going to be the public function because it's called from the character. So this is the entry point where we have the void picked up by. And we'll pass a pawn. This is the pawn who picked us up. Now this is going to be, let's go ahead and add the virtual tag because we may want to do additional work inside the pickup. Just like was collected, we may want to do additional work in child classes. So this is going to be a U function. It is Blueprint authority only because we only want this running on the server, and we'll put it in our pickup category. Okay, and let's add our tag here. This is the server side handling of being picked up. Okay, and as I said, we'll do some processing and then we'll make a call to the client side. This is where we're going to be broadcasting out the client on picked up by. So that is also a void function, client on picked up by, and we pass that same pawn pointer. And in this case, it's going to be a U function that is net multicast and unreliable. Now let's go ahead and add, this is the client side handling of being picked up. Now, let's take a look at this real quick. This is a function call that gets broadcast out and used by the clients. But if you recall, when we set up was collected, we made that a Blueprint native event because that would allow designers to do some implementation on in Blueprint through the editor and some implementation in C++. Well, we would like to use that same functionality. Unfortunately, Blueprint native events cannot be replicated. They can't be called out on the clients. They're not remote procedure calls. So what we are actually going to do is leverage this multicast function to call the wasCollected for us. Therefore, no one will ever actually need to call this function except inside this class, and it does not need to be virtual because none of our child classes are going to deal with it. Therefore, we're going to lock it down and make it private. So when we call the picked up by function on the server side, then it will do any processing it wants to do, and it will broadcast out a message. That message really is just going to be a relay that will then fire the wasCollected Blueprint native event for us. And that's how this is going to work. It's pretty crafty. Okay, so let's go ahead, now that we've declared these functions, let's go and implement those in our CPP file. I'm just going to drop down to the bottom here, and we'll put them down there at the bottom. This is fairly straightforward for the picked up by. Let's go ahead and say this is void a pickup, picked up by a pawn. Oh, and one other thing we wanted to do, like I said, we want to pass the pawn through the function calls, and we actually want to store that with our class so we can use it in that Blueprint native event. So let's go flip back over here and create that variable, which we will put in our protected section, and we'll call that the, it's a pawn, and we'll call it the pickup Instigator. That's the pawn who picked us up. And this is a U property. And we're going to make this visible anywhere. And we'll make it blueprint read only. And we'll put it in the pickup category. Okay, now this is the pawn who picked up the pickup. Okay, that's the pawn, the pickup Instigator. Okay, so flipping back over here, what we want to do in our server side is, of course, what's the first thing we do? You guessed it, do our role check, role authority. Even though this function should only be called on the server, and even though it's marked as blueprint authority only, we still want to put our authority guard in here if for no other reason than so anyone who's reading the code will know that that's how it works. And also it's our standard practice because that's how we roll. All right, so once we've got that, we're going to go ahead and set the pickup Instigator. So we have that value stored now on the server side, excuse me, just in case we need it. And then we're going to go ahead and notify clients of the picked up action. And we'll do that by calling, like I said, the client on picked up by, pass in the pawn. So store the pawn who picked up the pickup, just in case we need it. Okay, and that is all we need to do on the server side. The server is going to fire off that multicast function. Now it is to us to define that multicast function. So what is going to happen here? This is going to be the client version, so the void a pickup client on picked up by, and we add our underscore implementation, a pawn pointer, whoops, pawn. And here, once this is received on the client, what do we need to do? Well, we want to go ahead and store the pickup Instigator, because as you recall, the previous implementation was on the server side, so this is on the client side. So we also need to store that pickup Instigator so we can use it later. And then we're going to go ahead and call wasCollected. So basically we store the pawn who picked up the pickup. This is on the client. And then we are going to fire the blueprint native event which itself cannot be replicated. Okay, so that is pretty much all we need to do. So once the client receives this call, we're going to store the pickup instigator value, and we're going to fire off the wasCollected function. And that wasCollected function will then allow clients to do stuff. Okay, so that's pretty much all we need to do here on the base class. But as you recall, for batteries, they want to do something else. They also want to destroy themselves when they're picked up. Because they're picked up, they give the pawn or the player energy, and then they go away. So we need to add that, and that all happens on the server side, of course, where all of our authoritative gameplay functionality occurs. So let's go ahead and just copy this signature, switch over to our battery pickup class, and paste that in. This is here, and we're going to make this an override. And this is the server-side handling being picked up by the child class. Okay, so now we need to go ahead and implement this. So I'm going to try my control period and see if it actually creates that signature for us in the CPP file. And it did. Hooray, we'll just escape and switch over to that, and here it is. So I didn't have to type it myself. And now, of course, we first of all want to do our super call. So we call the super version, as is standard practice, picked up by pass the pawn. And this is so that the base class or the parent class can do stuff. Then, of course, let's do our check. Make sure we're actually on the server. And if we are, then what do we want to do? Well, in this case, the battery wants to destroy itself. But let's hold on for a second. If we destroy ourselves immediately, we have to understand that there is a real time difference between the server calling that multicast function and the function traveling over the internet and arriving at the clients and then playing some visual effects or sound effects. If we call destroy immediately, there is a high likelihood that the client will never be able to execute the VFX or the sounds because the object will be destroyed right out from under it. So instead, we need to schedule this pickup for being deleted at some point later. Now, we happen to have a function call to do that, and it is called setLifespan. And we also know about how long we want that to happen in the case of batteries. So we're going to go ahead and put in a hard-coded value for that, just for this purpose, because we already know batteries will take about 2 seconds to go ahead and play some VFX, and that should give the clients enough time to do it. Of course, we can make this a replicated variable or whatever, but it's not really that important. We're just going to go ahead and give it 2 seconds. So this is to give clients time to play VFX, etc. before destroying the battery. Okay, so having done that, we can then go back, think back through our functionality where we called wasCollected. The wasCollected implementation handled destroying it, which is the function just here above, and we do not need that call to destroy. Since we don't need the call to destroy, the wasCollected implementation in C++ for the battery doesn't really have much of anything to do for now. So we could go ahead and wipe it out if we wanted to. In fact, we're going to go ahead and do that because we don't have any use for it. So let's go ahead and get rid of it to save that virtual function call. Switch back over to our header file and delete that there as well. So now we've streamlined our code a little bit, get rid of that unnecessary call. Okay, so now what we've done is we've set up the handling of the pickup both on the server side and then broadcasting out to the clients. Once the call reaches the clients, they fire the wasCollected blueprint native event for us, which is great, and then everything will work wonderfully. We only need to do 2 more things before this will work. One is, if you recall from a few videos ago, I mentioned that we were going to need to do something in the pickup base class, the parent class constructor. And here's why. Because static mesh actors, by default, disable overlap events. Well, guess what? That's exactly how our pickup system works, by using overlap events. Therefore, we need to re-enable those overlap events. And we'll do that here by grabbing the static mesh component and setting B generate overlap events to true. So we're doing that because that's how our system works. We need to do overlap events. So we're going to make a note: the static mesh actor disables overlap events by default, which we need to re-enable. Okay, so now those actual overlap events will work. And that is pretty much everything we needed to do for additional new stuff. We can now return back to our character where we were calling wasCollected and say, okay, what is the new way to do things? Well, because we know we're on the server, we're going to call the pickups server handling, which is picked up by, and we pass in the pawn. Well, guess what? That's this character. So we use the keyword this, which is a reference to this character. The character is derived from pawn, so we are good to go. So we're going to now do the handling on the server, which will handle calling all the clients and so forth, and then we're going to set the battery to deactivate the battery. And that is all we need to do. So let's go ahead and compile. Now once that's done, we're going to flip over to the editor and we'll actually check this out and verify that it's all working for us. So I'm going to do that just now. Switch over here to the editor. There's one other thing we need to do. Actually, there's two. The first is we need to go to our blueprints, to our battery. Since we already we derived a blueprint class from the battery. We need to go in there and verify that our collision value is set to generate overlap events. It's possible that when you open this, it's going to look like this, where because that value is disabled, that the generate overlap events will be unchecked, and the little yellow arrow should appear because that's not the default. So click the arrow so it goes back to default, which is on. Compile and save. Then we're done with that. And last, we need to actually set the button click. So go to our settings, our project settings. We're going to go down to input, and whoops, I already did this. I'll do it one more time. Go up here to our action mappings under input, click the plus sign. We're going to call this what we named it in that input handling code called collect pickups, and we're going to give it a button. So I'm going to go ahead and give it the keyboard, the standard kind of use button in first-person shooters and stuff. We'll go with E, the E key. On the keyboard, scroll down, there's E. Bingo. Okay, so that is the key we're going to use to do this, is the E key. Now, if all is right with the world, we should be able to click play, and we'll start seeing batteries drop. I'll run over here and press E, and the battery disappeared. Now, of course, it took time because we put that set lifespan to 2 seconds. So when I collect a bunch of batteries, you'll probably hear my key click on the keyboard right now. And then you wait 2 seconds, and all those batteries that were within my collection sphere have vanished. So they have been collected, and the system is working as we expect. So let me switch over here to the listen server. Do the same thing. Hit the E key to collect some batteries. Bingo. Now you can imagine, hopefully, that in the future there's going to be these lightning effects and things that get played for us before those batteries disappear. So it's not going to be this sort of awkward inaction for 2 seconds where nothing seems to be occurring. That's just temporary until we implement that VFX functionality, which we will start working on, because in the next video we're going to turn our attention to power, and we'll start adding some functionality to deal with power from the pickups and the character and all of those cool things. So I will see you in the next video.